Hello, everyone. Dear virtual attendees, hope you're all indoors in isolation and staying safe and healthy in these unprecedented times. My name is Dipti Desai, and I'm a co-chair for both TICON Health Track and the Thai Global Health Initiative. Welcome to the first of many healthcare webinars we will be bringing to you by Thai. Kicking off today's premier event is our board member and charter member, Abhi Gholap. Abhi is an alumnus of IIT Mumbai and Stanford Graduate School of Business. He's a founder and chairman of Optra Ventures and has over 20 years of experience in the health tech industry. His experience in the health sector ranges from Fortune 500 companies to early stage startups in diagnostics and therapeutics. Abhi is an angel investor with both Sandhill Angels and the Band of Angels. He's an inventor, an author, has 18 patents in the US and several publications, including those in Nature and Lancet. Please join me in welcoming Abhi Gholap, host and moderator for COVID-19 Fact versus Fiction. Abhi?
Thank you, Dipti. Hi, very good morning from California. On behalf of Thai Silicon Valley and Thai Silicon Valley chapter focusing on health tech, I, Abhi Gholap, welcome you all for today's webinar on COVID-19, Facts versus Fiction. Thai Silicon Valley is the largest and the founding chapter of Thai brand. Thai is a non-profit organization founded in 1992, and this is for and by successful entrepreneurs, corporate executives, and senior professionals. Our chapter provides technology entrepreneurs with mentoring services, networking opportunities, startup-related education, funding, and incubating. Today, we are certainly in very challenging times. This has never happened to anybody else so far in our life, because after 100 years of such episode that happened in 1918, we are experiencing it today. And in this experiencing is going to be very challenging if we do not have rights, facts, and figures in front of us. And that is where we have today invited 4 of the thought leaders in this space: one microbiologist, one immunologist, one medical researcher, and a physician. As we start discussing today more about the COVID-19 pandemic, what are the facts involved in that, and what are the myths around it, let me welcome our panelists today, starting with Dr. Pat Murray, who is a VP at Becton Dickinson Life Sciences, Dr. Achal Pashine, who is the Executive Director of Immuno-Oncology and Autoimmunity, Dr. Swami Iyer, Professor of Medicine at MD Anderson Cancer Center, and Dr. Ram Subramaniam, a specialist in infectious diseases. I would request Dr. Pat Murray to give more information about himself, and then we'll start with our questions and answers to him.
Well, thank you very much, Abhi. I've been in the field of clinical microbiology for almost 50 years. For about 40 years, I directed clinical laboratories, the last of which, for 10 years, I was chief of microbiology at the National Institutes of Health. After I retired from the NIH, I moved to Becton Dickinson, where I'm now vice president of global scientific affairs for the BD diagnostic businesses.
Welcome, Dr. Murray. Now, may I request Dr. Achal Pashine to introduce himself, please?
Hi, my name is Achal Pashine. I'm a cellular immunologist by training. I did my PhD at National Institute of Immunology in New Delhi and did various postdocs at Stanford University Medical College of Georgia. Following that, then I was a cellular immunologist leading immunology as well as immuno-oncology programs in various companies, including Bristol Myers Squibb, Hoffmann La Roche, GSK, as well as now at Arvinas Incorporation.
Thank you, Dr. Pashine. May I request Dr. Ram Subramanian to introduce, please?
Hi, I'm Ram. I'm an adult clinical infectious diseases physician working out of Apollo Hospitals in Chennai. I trained from Chennai and then did my post-graduation in the Postgraduate Institute in Chandigarh, and then spent a few years in London before I came back to India about 2 decades ago, and I've been here ever since. I also run a multi-specialty clinic with heavy leaning towards adult immunization and travel-related issues. I'm passionate about adult vaccines, and we are now beginning to see the challenge of COVID in India.
Thank you, Dr. Ram. For some reason, we are unable to connect Dr. Iyer. As soon as he is available, we will have
I'm
him
here.
on the board. Oh, he's here. Okay, excellent.
I'm here.
All right. Okay,
You can't
so,
recognize
Dr.
me in
Iyer.
my mask. So this is Swami Iyer. I'm a professor of medicine at MD Anderson in the Department of Lymphoma and Myeloma. Also immunology by training. Worked with the Eckert Podak, who discovered perforin molecules and CD8s and several other things, including CD30. Of course, the reason we are here is because of how it affects us, particularly in our patient population. The cancer patients are very vulnerable and susceptible, and very happy to join this panel and to talk about what we are doing and what the others are doing as well.
Excellent. So with this wonderful panel that we have today with us, let's discuss more about this topic. But while we are discussing this topic, I would also like to request our audiences to send their questions. I will also request my co-chair, Dr. Dipti Desai, to compile those questions, and we can address those questions as we come to the end of these discussions with the panel. So to begin with, I would request Dr. Murray to give us some insight into this new virus, COVID-19, and how different is this compared to SARS or MERS that we all have come across during the last 10 to 15 years? Dr. Murray?
Well, it's a very interesting question. If you think about the coronaviruses, it's a very large family of viruses, and think of that as branches. One very large branch of this tree is viruses that infect insects and animals, but really don't cause any problems with humans. However, there's another branch that does infect humans, and there's at least 4 different coronaviruses that are responsible for what we recognize as the common cold. And so if we think about that, that's not something that we get terribly concerned about as more of an inconvenience. But then using that as a model, we look at one more branch in this tree, and we see the viruses that cause very severe human disease. Now, interestingly, the SARS virus, the original SARS virus that we saw in 2002, the MERS virus that we saw in 2009, and the current coronavirus that we see, the SARS coronavirus 2, all of these viruses originate from the bat branch of this tree. Bats spend their lives eating insects, and they get exposed to many different coronaviruses in this process. And some of those coronaviruses are able to mutate and then infect animals. Specifically with the original coronavirus, it infected the civet cat that was sold in China in the live markets. And that virus was also able then to transfer from the civet into humans and cause human disease. Now, interestingly, it was first seen in November 2002, and for 7 months we saw tremendous devastation with that virus. It infected more than 8,000, it infected, I think, close to 30,000 individuals. About 10% of those died from that infection. But interestingly, after those 7 months, the virus disappeared and we didn't see it again. It wasn't until a few years later that we saw the evolution of the MERS virus, again causing very serious disease. It was seen in the Saudi Arabia area, and it was transmitted from bats to camels to humans. And because camels are integrated into the lifestyle in Saudi Arabia, we continue to see infections with MERS every single year. Interestingly, that was a much more lethal virus, and about 1/3 of the people that were infected with the MERS virus ended up dying from those infections. This most current virus was first seen in December 2019 in Wuhan, China. We don't know what the intermediate host is, although it's suspected to be one of the animals is the pangolin anteater. But it moved into the human population, and based on a couple of mutations in the virus, it was able to be then passed from animals to humans and then human to human. And that is the reason why we see such widespread dissemination of this virus, where now it infects virtually every country in the world, and we see really devastating disease. It's not as lethal as the original SARS virus or the MERS virus. Maybe 1% to 2% of the individuals who do get infected with it will develop disease. And as many as 40% of the people that get infected will have either asymptomatic or very mild disease. So it's a different sort of virus than what we've seen before, but still, because of the widespread dissemination, it's caused both medical and economic devastation.
Yeah, thank you, Dr. Murray. So, like when we are talking about this as infection, we as a human being, we are having a wonderful system of fighting this kind of the infections through our immunity. So let me ask this question to our immunologist, Dr. Pashine. What's happening? Why is our body not able to fight out this virus through our own existing immune system?
Yeah, so that's a great question. Actually, the myth is that our body does not fight this infection. It does. Actually, 80% of the patients that are infected with this virus are not critical. Only 20% of the patients are very critical. So let me, before I give you the answer, also point out that the problem with this virus is the simultaneous nature of infections that happen and overwhelm the medical system. So it is not so much that the body is not able to fight, it is about the nature of the infection, the infectivity of this virus. In fact, as Dr. Murray suggested, it's not as lethal as MERS and SARS infections. So let me just go back to a few of the issues with this virus. So when a virus infects us through the respiratory system, we develop first an innate immunity, which is a non-specific immunity to take care of the virus, followed by an adaptive immunity, which is a very specific way of taking care of the virus, which happens for this virus as it happens for other viruses. Now, the particular issue with this virus is that the way it infects is via a receptor called ACE2. And ACE2 is very well expressed in the lung, kidneys, liver, GI tract. So, this virus also has the ability to go beyond the lung to the other organs and have a multi-organ infection, so to say. So the problem is also the anatomical location. If the virus is restricted to the upper part of the nasopharynx, then it's not as lethal as if it goes to the lower respiratory tract, causing pneumonia. So those are some of the facts around how the immune system works for this virus. Now, the other issue, which is also true for other infectious diseases, is that the population that is old has underlying diseases like CV or diabetes, obesity. Those patients are more vulnerable. And these patients, the older population, also has what is called immune senescent. They are not as reactive to the foreign agents as, say, teenagers are. So there are a variety of issues immunologically that are happening that overwhelm the system. The last point is that actually, if you look at the very critical patients for this virus, the ones that are going acute respiratory distress syndrome, i.e. the virus is in the lung and there is a failure of oxygen saturation from the lung. If you look at the biology of that, it looks like the viral induced cytokines, so our immune system trying to fight this virus is actually causing the collateral damage, and that damage is causing the lung failure. So I would say that it's not that the immune system is not active. Immune system is perhaps active too much at some locations and not active at other locations. And the last point I would mention is the infectivity of this virus that Dr. Murray mentioned as well, that just the nature of the spread of this virus also complicates beyond the immune system, the simultaneous nature of the infections.
Yeah, thank you, Dr. Pashine. So let me now go to Dr. Iyer. Dr. Iyer, we have heard that the drug called hydroxychloroquine, and it was very also evident through lots of news, is seen to be like, really working very effective to treat this kind of the patients who are infected with COVID-19. I mean, how true is this, and what exactly is the situation around this kind of a drug?
No, a good question. I think as we are progressing very logically into this discussion, and one question leads to the other. I want to also mention that the reason why hydroxychloroquine seems to work in the situation is because of what Dr. Pashine talked about. The entry point for the virus into the respiratory cell, the cell that gets infected, is ACE2. Of course, there is this immune system, the innate immune system that he talked about, that should potentially take this virus particle and recognize them and present it to the adaptive immune system that makes antibodies and whatnot. So that process can take about 10 to 14 days. In other words, the innate immune system sometimes helps, and he pointed out in the right way that the innate immune system, if it is able to do so, it works very well. And it's illustrated by a very nice case report that came from Australia. A 47-year-old lady who did nothing, who was just in the hospital, was given oxygen, and 14 days later, the antibodies came along and she was able to go home. And it doesn't happen for the most part in many of the other people. And Dr. Pashine already alluded to what happens when the immune system goes berserk. And what does hydroxychloroquine do in this situation? So while the virus has entered the cell, it goes through to covered particles inside the cell. And these are called endosomes. And these endosomes, as it gets into the ACE2 receptor, it sort of gets pinched into the cell. And it floats around in the cell through these endosomes. And a good example I'll give you is if you've gone to the theme park in Disney, you go on those rides and you sit on a boat, and the boat is, you think the boat is going on water, but actually going on rails. So these endosomes also track through the cell in the form of a rail, and then they get to the machinery where it's able to copy itself, the 3D printer, if you will. And this is called the ribosome. The ribosome box is where this virus hijacks that 3D printer, and it's able to make copies of itself. And then it comes out in the form of, again, endosomes, and it gets pinched out. So this process of getting in and getting out is through these endosomes. What drugs like hydroxychloroquine do is that they slow this process. The same thing with the theme park. And the boats are going, and then they stop those boats, and then all those endosomes come close to each other. So hydroxychloroquine is a weak base. It increases the pH of these endosomes, and then prevents this process and slows them down. In other words, it's not a very specific drug. It slows things down. And that's the reason why it seems to work in a particular instance, in those 10 to 14 days for this process to be recognized by the immune system. There are more specific drugs, and I'm sure we'll talk more about that. But the advantage of the hydroxychloroquine is that it's able to slow this down. It's not specific. For the most part, it's been safe and used for malaria prophylaxis. But the big problem is, in this day and age, we're using a lot of other medications that can enhance some of the side effects, particularly the heart, as you saw in some of the studies that are coming out rapidly. And so the clear advantage is that it can work, it can slow things, but is it a slam dunk? That data is not very clear yet. There may be still a big role for hydroxychloroquine. Got it.
Okay, thank you. So Dr. Ram, I would have another question. As you represent our South Asian segment of the world, and we see that this is all started from China, but then eventually people in Italy got severely affected, and then Spain, and then France, and then Germany, and then it came to New York, and it is like a fire here. So from all this perspective, we still see those kind of the pockets in which this virus is really causing big damage. So can you tell us something more about it? Why there are different races, different countries are reacting different ways, and in one side there is so many deaths are happening in other countries like maybe Bangladesh or Sri Lanka. This virus is not impacting that much. I mean, what could be the reason for such kind of a differentiation between these geographies? Dr. Ram, you're on mute.
Sorry. I don't think there is any proven scientific reason to say why certain populations are more resistant to the virus than the others. But common sense tells me that all of us are susceptible to this virus. Now, this is a novel mutated virus for which none of us have any immunity, which means all of us are equally susceptible to get the infection. Now, what complications happen are directly related. The only strong factor which has been shown to be associated with increasing complications is an increase in age. People over the age of 65 are at a higher risk of running into complications and end up dying. It has been shown that the people over the age of 80 are, there is a possibility of over 15% of people over the 80 of dying because of this. And the younger they are, and especially surprisingly, because this viral infection is very closely associated both in terms of how it is spread and how it causes infection and how it causes problems with the common flu. The flu has been shown to have severe consequences in the elderly and in the very young children. And this disease, surprisingly, does not affect young children. It causes very mild infection, and most of the young children are in fact asymptomatic and may be responsible for transmitting the infection. Again, even pregnant women, when they develop the flu, can run into more complications, but surprisingly, the COVID-19 has not shown to have any serious consequences yet in pregnant women. So, as far as risk of infection or why more people die, it is only the age. Now, why, as you asked, some countries, specifically Italy and US, have higher complications is the fact that one, there is a direct link between Wuhan and Italy in the textile industry. So the travel between both Italy and Wuhan is very high. So as soon as it started in Wuhan, it reached Italy quite early, and Italy has a very high population of the elderly people. Other than Japan, the next country with a high level of, or a high percentage of population with people over the age of 60 is in Italy. So it went into most of these old age homes where a lot of caretakers died, and a lot of these elderly women and men living in these long stay homes, they perished. So the main reasons for mortality in Italy were the elderly, especially in affluent homes in certain parts where there were hotspots in Italy. Similarly, the link between China and the US is also pretty strong. So the travel was the reason why the infection reached these countries quite early. Now, countries like India have very minimal links with China in terms of travel, whether it is Bangladesh or Sri Lanka or India. The links with China is a little, tenuous, and the chances of the virus moving from China to these countries in the early part of the epidemic is pretty low. So all these are protective. And secondly, the fact that India went into lockdown way back on the 23rd of March, I think act as a major deterrent in the spread of this infection. So I don't think we have just been lucky so far. We have been able to flatten the infection, flatten the curve in India, but I think it is going to last much longer, probably not as a deluge, but definitely as a consistent trickle. It's going to come in the next few days and weeks.
Yeah. Thank you for this detailed explanation. This also brings me to another question of mine. This related to the vaccination, right? People said that BCG vaccination has some relation in controlling this kind of the virus. And then in countries like India, BCG vaccination is there since like 1948 and so on and so forth. So how much truth is this in this assumption?
See, this is a very interesting theory. It is believed that the BCG vaccine acts as an immunomodulator and probably affords some sort of protection against COVID-19. The study based on this conjuncture was purely an ecological study, which looked at the comparison between populations where BCG had been given versus the other countries where BCG had not been given, showed that there was a significant difference. But all ecological studies are prone to a very, very high degree of error and bias. And I don't think there's any rationale so far yet scientifically to say that it helps. There are several studies which have started, and even the WHO has very strongly commented on its website that this is purely an association which definitely needs validation. And as of now, there is no reason to say that BCG is protective and that people should take BCG vaccines, because there are a lot of people asking, elderly people asking whether they should take if they have not had the vaccine before. And there is absolutely no role yet.
And just to add to this point, I also came across a statement by ICMR professional, he's mentioning that BCG vaccination effect is only for 15 years. So that's where they were also ruling it out. Yeah, thank you for that. So Dr. Iyer, you were talking about another medication, in addition to the hydroxychloroquine that we talked about. And that's what is by this Gilead's experimental drug, remdesivir. What do you say about that? I mean, is that really a magic drug against this disease?
So remdesivir is a specific drug that works on that possibility that the virus can replicate itself. It needs an enzyme called RNA-dependent polymerase, so that allows itself to replicate. Remdesivir goes and sits on the polymerase and prevents that from working properly, so it cannot copy itself. It cannot have the raw material to copy itself. And the studies were done in the past with Ebola and a few other pandemics. And for whatever reason, it was shelved. In fact, the coronavirus, as Dr. Maria was talking about earlier, it does not just affect humans, it also affects certain animals. And cats, for example, get a different form of coronavirus. It's called feline infective peritonitis or inflammatory peritonitis. And remdesivir actually was tested in cats, and it seemed to help in those cohorts. So in other words, you had a body of data that was preclinical and also clinical, showing that it worked. And since the enzyme that causes these viruses, whether it's Ebola virus, again, a single-stranded RNA virus, or this virus, the mechanism is likely to be the same. Gilead came along with doing this in a compassionate basis, and the paper just came out, the compassionate use protocols for patients who were in the ICU. There were about 50-odd patients, and the responses were modest. Obviously, you have to understand that the clinical research sometimes happens very slowly, but this is an exceptional circumstance, and within a very short period of time, you have seen some responses. So, and as clinical investigators and as researchers, we take, whereas it's very encouraging and promising that it can actually change the life cycle of this virus, the data, you have to interpret the data is what is there for you to see and interpret, right? So it looks promising, it's safe, number one. Number two is that it seems to help a lot of these patients who are in the ICU. Now, larger studies need to be done. I understand that Gilead is giving out a million odd of this tablets out to patients across the board. You have to understand clinically, and when you look at clinical studies, and you have to look at what the endpoints of studies are. For a patient in the ICU, the endpoints are very different from somebody who's not so sick. And it's very different from somebody who is asymptomatic and who has just mild infection. The goal there is to prevent them from getting things worse and getting to the hospital. The hospital patients, the goal is to make sure they don't get to the ICU. Patients who are in the ICU, you want to make sure that they don't die, right? So these are very broad strokes of what the endpoints could be. So for the ICU patients, it did seem to make a difference to some extent. And I think it looks very promising. And I would say that remdesivir perhaps is going to be one of the main drugs to treat the SARS-CoV-2.
Okay. And you also made a mention about the testing, and probably that's where I would now request Dr. Pashine to give us a little bit more insight about the type of the testing. We understand there is the test that got launched a few weeks back, which is like a PCR based, but then recently people are talking about this rapid testing using this antibody kit. So can you help us understand more about the type of testing and how is that happening?
Sure, Abhi, so let me tackle this question two ways. First, let's explain the testing and then the ramification of that, because it's very important. Some of the news coming out of California is important as well to discuss with respect to the antibody test, for example. So there are essentially two kinds of tests thematically. One is a real-time PCR test, which is essentially looking for and amplifying the nucleic acid from the virus itself. So, the virus genome is published, it's an RNA virus. You devise the probes and you expand that probe, amplify that probe essentially in a machine called quantitative PCR, and then look for a signature, are you positive or negative? And there are quantitative ways of looking at what is positive and negative. What that test does is essentially tell you if you have the current presence of the nucleic acid in the nasopharyngeal swab, for example, from where this is usually taken. The second test, which is discussed, is an antibody test. And what it is saying is that how successful has your immune system been to develop the antibody against this virus. So in that case, you take a finger prick or other blood plasma and look for the antibody using a technique called ELISA, which essentially is to look for a protein in the body that reacts to the virus and binds to it. And there are multiple ways of doing ELISAs. Essential end product is, again, a quantitative positive or a negative test. The third one is to look for, using the monoclonal antibody, look for the proteins of the virus, right? So look for the antigen, essentially a protein encoded by the virus, rather than the nucleic acid. And it also can look at the presence of the infectious agent in your body. So these are three thematic ways how you can look at this virus, as well as your immune system's ability to look at this virus. Now, one thing is that antibody test does not necessarily mean that it is a successful immunity, because it depends on many things. It depends on the titer, it depends on the affinity of the antibody, i.e. how tightly they bind and neutralize this virus. None of this is very clear from just looking at a positive or negative response to the antibody. So those are some of the things. Now, going back to the antibody, there are something called, because people hear these terms online, IgM antibody, IgG antibody, as well as IgA antibody. All they are different versions of the same protein. The IgM antibodies come first, are low affinity, weak antibodies. IgG antibodies are more matured antibodies that come later, about day 12 or 13, as Dr. Iyer suggested. And then IgA antibodies, because lungs are where, as well as other epithelial surfaces, is where the IgA is made. People look for that as well. Now, let me go back to the California question, because it has been in a lot of people's mind. Recently, a study came out from California, is on a bioRxiv, non-peer reviewed publication, that suggests that if you take the random samples of Californians, especially from Santa Clara County, and look for the antibody positivity, they are seeing a lot of positive responses, more positive than if you were to look for real-time PCR-based infectious agent in your body. I think they look at 50 people out of 3,300 people that they randomly tested. And that is quite high. That is around 1 to 1.2% of the infectivity. And that seemed to suggest that a lot more patients were infected than what has been revealed by the real-time PCR test. And this is an important thing to know, because it can be perceived as these people having immunity and can go back to work, for example. So there are many ramifications of that. Now, with this fact that has been published in this paper, let me also put some caveats out. The ELISA test that looks for the antibody against the virus, we do not know the specificity of this test yet. And as Dr. Murray pointed out very early on, there are many more coronaviruses. There are 4 different coronaviruses that are usually present in human and cause common cold and other variety of very mild diseases. And this is the time that is also the common cold season. And I'm just worried that that high propensity that California study saw, was it related to the cross-reactivity of that test with other coronaviruses, would negate some of the output that study purported. So these are about, to conclude, there are 2 tests, essentially thematically, nucleic acid test, antibody test, and then the ramifications of how to open up the country is dependent on assessing how many people are immune to the virus. And my own perception is that current tests are not able to look at the neutralizing ability of the immune people yet.
Yeah, thank you. And one of the tests, like antibody test, recently we saw in the news that Becton Dickinson's product was cleared for this type of a testing. So, and we are fortunate to have Dr. Murray also here today. So would you like to say something about it, Dr. Murray?
Yeah, maybe let me work a little bit off of what Dr. Pasheen said in terms of diagnostics, because I think it's very important for everybody to be able to put in perspective how to use these various diagnostics. The challenge that we hear so much about is that we have a shortage of the swabs that are necessary to collect the nasal specimens and the throat specimens. Basically, there's 4 different types of swabs that are made the two most common, the polyester and the rayon swabs, in fact, were not approved for use for nasal specimens until very recently. The polyester about a week ago, and the rayon in the next day or two, we're going to hear from the FDA that it's approved the use of those swabs. So the bottleneck in collection of specimens is going to be eliminated. But the next bottleneck, the really critical one, is the capacity of laboratories to perform the test. And right now, the volume of tests that are going to the laboratory is overwhelming, and they're not able to keep up with that. And that's why we hear of, even though we may have a test that you can get a result in a couple of hours, those results are not being reported for days. And it's because there's just too much work going into the laboratories. So how do we eliminate that? We eliminate it by being able to do testing outside the laboratory. And of the three tests that Dr. Prasheen talked about, the antigen test and the serology test, or the antibody test, are two tests that can, in fact, in certain circumstances, be tested outside the laboratory where the specimens are being collected. Those are called point of care tests. And so the antigen test, not as sensitive as the nucleic acid amplification test that we see so much of, but still they can screen patients and allow you to say maybe 70% of the patients that are truly positive will be detected by these antigen tests. The serology test is a little bit different. The serology is trying to say, have you been exposed to the virus? And as you point out, BD has a test that we're introducing. It's going through the FDA approval process now, but it is available for use for a 2-week period. And the goal of that test is that you can detect both the IgM antibody and the IgG antibody at the patient site, so that we'll eliminate sending those types of tests to the laboratory and be able to free up some of the testing time that the laboratories so desperately need. Now, the challenge with those tests, again, as has been pointed out, is that they're not as specific as what we would like to see. We ultimately want to see a test that's very specific for this coronavirus and that does not detect the more common ones that we see annually that cause our common cold infections. And I think the value of these serology tests is really going to be measured by how specific they are. The last point is that what we don't know yet is the presence of antibodies. Does that mean that you're immune to infection? And it's a question that is being examined. There's a very large study at the NIH. It's going to enroll 10,000 patients to try to address this question. But ultimately, that's what we want to know. If I develop antibodies, that means that I probably have been exposed, and I want to know, will I be protected from another infection? Mm-hmm. That's the question we need the answer to.
Yeah, got it. Thank you. So, another question connected with this is like social distancing, right? I mean, everybody's hearing this term like maybe 20 times a day now, and all of us are observing that social distancing phenomena. But then people are also talking about herd immunity. So how does that work, Dr. Murray? I mean, what exactly is this herd immunity, and how can we just, build that kind of an immunity in like whole of the population? Any thoughts?
Yeah, it's a difficult question. The social distancing means that we try to avoid contact with each other where one of us may have an asymptomatic infection and we're shedding virus. I think one of the points that hasn't been made yet is that when you look at this particular virus, it's different from most other viruses. This particular virus, the most virus that's being shed by somebody that's infected is right at the time they initially present. It's actually even before they present, they're shedding very large amounts of virus. So our neighbor who looks perfectly healthy, in fact, could have an infection with this virus and could be contagious for us. So by social distancing, we've eliminated, or we've reduced the opportunity for this virus to spread in the population. But that has another consequence. If the virus doesn't spread in the population, that means that a large proportion of us are still susceptible. roughly, if you look at the testing that's been done in the United States, I use that as an example, only about 1 to 2% of all the people in the United States have had a test performed. That means 98% are either, they're clearly unknown whether they've been infected or not. If we assume that 95% of the population is still susceptible, we have to be very careful when we start congregating again, because this virus is still in our community. The virus still can spread from person to person. And as was mentioned earlier, this virus is highly infectious and we're all susceptible, some more than others. And so we have to be very careful as we release the control that we've placed on this to be able to avoid infections. Herd immunity, it's said that you should have at least 50 to 60% of the population having been exposed and develop antibodies. So we're nowhere close to that. So I think herd immunity is maybe something we think of in the future. It's not going to protect us today.
Yeah, thank you for that. So maybe I will ask Dr. Iyer about how to get out of this. I mean, what's an exit strategy, as one can say, from this lockdown? Many countries got into the lockdown. Country like India got into lockdown much earlier compared to other countries. But, getting into lockdown was kind of a one-way process, right? I mean, how do you decide and when can you decide to get out of lockdown and come back to the normalcy?
So it's a great question, Abhi. I think every country has been tracking this virus, and several epidemiologists who have been tracking this. And as Dr. Mari mentioned, it is a function of the geographic location. It's also the number of tests that are done, the number of positives that came out of the test, and the daily positivity. And in some ways, it's also, at least in the United States, to look at the capacity, the hospital capacity for handling those number of patients, with the projection that you might have a peak of infection, and including the utilization of ventilators and ICU. So all these are projections that are being made. At least in the US, you have a daily tracker that different groups have been putting out, the Johns Hopkins group, the CDC. Every state has a Department of Health that puts out these trackers, and we've been looking at those trackers. And so where I am in Houston, in Texas, for example, the peak was supposed to happen this week. And for the first time, you're actually starting to see a blip. And why are these things important? So it's like everything else. You need trends, and these trends have to go on for some period of time. And then you also have projections for the future. So people who make these decisions have to look at this data. This is a data-driven process. And what your projections. And so, and as Dr. Murray rightfully pointed out, there's only one person in the US have been tested, unlike Taiwan or South Korea or other countries that have done so. In other words, if you allow people to come out and then you don't really have that 50 to 60% of the population who might have the infection. So you might have a second wave of infection, as was seen in clusters in Singapore, as was seen in South Korea. So in other words, I think the exit strategy should consist of this data-driven process, a staggered opening of businesses, continuing to practice social distancing, continuing to do the best you can to try and reduce the chances of infection, keeping the vulnerable people out of this, right? Like the older people and people who have immunosuppressed condition. We see a lot of patients with cancer. I can tell you the number of times I have to readmit a patient twice for COVID infection within a span of 4 weeks, and with a COVID positivity, which means that for some reason we still don't understand this virus still persists in these patients, and that can be scary, at least in our cancer patient population. So the exit strategy has to be individualized to countries, and it has to be data driven in some way.
Yeah. Okay, got it. So, and again, for the audiences, we are receiving your questions, and we are keeping a track of those questions as well. But looks like many of these questions that you people are asking are getting already answered from this panelist. So we'll definitely be asking those specific questions which are not covered in these discussions. So as we understand, about the present scenario about the vaccines, Dr. Ram, will you be able to give us some insight about the stage of vaccine? Because we believe that's the only savior for us, right? You are on the mute, doctor.
Most of the viral infections, what we have seen by experience, stimulate the body's immune system. And if the body's immune system is able to produce what we call as neutralizing antibodies, which can kill the virus, the person generally recovers. Which means if the virus is unable to overwhelm the body's immunity, the person is able to develop an immune response to the infection so that the virus infection is cleared. So based on this concept, because when this happens naturally, the virus sometimes can kill the host, the concept of vaccination came up where they took the virus, they inactivated it either with heat or other chemicals or whatever, and then injected a weak virus into the system, which stimulated the body to produce an immune response so that when subsequently the virus infection naturally happened, the body could withstand it and get rid of the infection. That is a concept behind vaccination. So to make vaccines safe, instead of giving a killed vaccine or a weak vaccine, now they synthesize the vaccine protein or what aspect of the virus can initiate the response, and they manufacture it and use it as a vaccine to inject into hosts. So for that, we need to know the structure of the vaccine. And way back on the 11th of January, China managed to give us the genetic structure of this virus. So when the genetic structure is known, they are able to synthesize or chemically produce a vaccine which has the same antigen or the protein of the virus, which can induce the immune response. And surprisingly, within 2 months, on the 16th of March, the first clinical studies started. When I looked at the last count, there were more than 115 vaccine candidates for COVID, out of which almost 78 are confirmed, and out of which only about 4 or 5 have come to the human stage. Almost 73 of them were still in the pre-exploratory, pre-experimental or pre-human trial stage. We need to understand that the normal process of vaccine development takes at least 10 years. They accelerated the response for the Ebola virus vaccine, which came out in 5 years. And it is believed that the COVID-19 vaccine will probably be ready in 12 to 18 months, which is phenomenal. But we also need to understand that even if 115 candidates are there, there is over a 90% attrition in most of the vaccine development. And you also need to understand that you need an animal model for the vaccine to do studies on the animal before they are tested on man. So there are a lot of hurdles before we reach the expense involved, the cooperation between agencies. So we still have a long way to go. But as of now, apart from the herd immunity or a natural immunity which may protect us, the vaccine is probably the only option we have in blocking or stopping this pandemic.
Okay.
Abhi, can I just make one comment? It's more of a philosophical one, and really to emphasize the point that Ram made, and that is, it's much better to prevent a disease than to figure out the cure of the disease. And that's why vaccines are so important.
Absolutely. But then, Dr. Murray, you think, now that we are approaching summer season, would that help also to control and limit this transmission?
Well, I have some colleagues on this call that would say warm weather has not stopped the virus in their countries. No, I think we don't know. Just to be honest, there's a lot we don't know, and we have to admit that. We do look at the virus, the coronaviruses that cause the common cold, and yes, they seem to disappear for the most part during the summer. If you look at the SARS virus, the original SARS virus, it completely disappeared, but I think that's because of the intermediate host. If you look at the MERS virus, it persists, and Saudi Arabia is very warm. I've been there during the summer, so it doesn't seem to mind that temperature. I think the fact that this has been disseminated throughout the world and so many people are infected, there's going to be a reservoir of infected people that will continue to allow the circulation of this virus. So I would be very surprised if it disappears in the summer and doesn't reappear. I think we're going to be confronted with it for at least a few years.
Okay, thank you. Now that we are talking about, this as a pandemic, right? And we also heard in the news about the World Health Organization's role and everything, and that also created a little bit of confusion in mind of our citizens. So Dr. Pushini, would you like to tell us about, what is this World Health Organization supposed to do? And in such kind of pandemics where whole of the world, was caught off guard and then started shutting down one after another in terms of the geographical locations. What would have been a better way of communicating to whole of the world, saying that, hey, something like this is coming and be careful?
Yeah, no, that's an excellent question. So first of all, I'm not going to go into the politics of WHO and the funding as well as the noise that has been created around the whole situation. I'll just stick to the logic. As we all know, World Health Organization is a central body monitoring the health of the world, which is what its mission. And the mission seems to be that if you are healthy, then you can bring the peace and prosperity across the world. Now, the way I see and the way WHO has stated, there are three layers of how WHO can effectively work. The first is a sentinel layer, that it is a sentinel organization. Any new emerging infections, as well as danger to the world, such as the one that is currently experiencing, H1N1, Ebola, Zika, other things in the past, they keep an eye as a sentinel agency. Then the second one is because it is the body on behalf of the world that is working towards this, it has a second function or layer, so to say, where it can do the local mitigation. So where the infection is there, can you provide the resources, technical, economical, and otherwise, to keep it controlled in the geographical area where you see the signs. And then the third one is, once it becomes a pandemic, you need to have a coordinated world response, i.e. what are the procedures, what are the behaviors, what is the lesson learned from other countries that are ahead of you. So that coordinated response is needed. So I see WHO as a three layers: a sentinel organization, a resource providing organization, as well as then a central policy making organization when the pandemic does happen. I'll just give you a quick example that and again, I promise I'm not going to go to the politics, but America first does not necessarily mean that America only. In fact, we can benefit our country if we keep an eye on the infections happening around the world and keep them at their shores, not appearing here. So even if you are principally agreed to America first, I think it would be very good for us to help these central bodies. So, and maybe learn from the mistakes or learn from the communication issues that might have happened in this case and strengthen it rather than cut the cord there. And that's my personal perception around WHO. May I also take a couple of minutes, because just to be on the record, because we talked about BCG vaccination. I just as an immunologist want to provide that, and shifting gears from WHO to BCG. There are a lot of immunological issues around that concept of BCG. Immunologically, both the innate immunity as well as the adaptive immunity with respect to the BCG and how it will transmit or be efficacious in COVID, I think there are a lot of gaps that are needed. But I do agree that in the situation like what we are now, desperate situation needs desperate measure, and I fully support, because of the safety of the vaccine, that we should try it. But I have my reservations around whether it will be efficacious in this current case.
Yeah, thank you. And we just have 2 more minutes, so I will just take a quick minute on the recent question that we just now got here about the plasma therapy, the convalescent serum therapy. So may I request your views, Dr. Ram, on this?
Yeah, this is a promising therapy. It has been around for over 100 years since the Spanish flu. Subsequently, it was tried during the H1N1 pandemic in 2009, and then also during the Ebola infection. It is basically harvesting the blood or the plasma, which is the liquid part of the blood, from patients who have recovered from the COVID, for example, with the presumption that they will have a high level of antibodies which are protective. And this will act as a passive immunization, or taking the antibodies and injecting it into a patient who is unwell so that he can fight the infection better. There are still a lot of studies in the observational stage. We still have a long way to go. It involves taking the plasma out, taking the blood out, doing what is called apheresis, which is processing it and sending the blood back to the patient and harvesting only the plasma which contains the antibodies. This is done because you can take more plasma from each patient. So every 2 weeks, a person can donate the plasma rather than once in 3 months, which is what a person can do if he's donating blood. So this is being looked at as a promising therapy. There are several studies, though involving only 5 patients or 10 patients in each study. They are all observational, but now studies are on. It looks promising, but we still have a lot to learn because we are still not sure whether the problem of complications and death occurs because of an overwhelming immune response by an elderly patient, which causes what we have referred to as a cytokine storm, or is it the virus actively destroying the organs and causing damage? So we have to wait and see.
Thank you so much. And this brings to the end of our session today. I really appreciate all the time taken by Dr. Murray, Dr. Iyer, Dr. Ram, as well as Dr. Pashine to come and educate our audiences today. And I am very much thankful to TAI, an organization that has sponsored this webinar today to educate all the citizens. Again, thank you for your time. Have a good day, good night, and keep yourself safe inside the homes. And let's beat this virus. Thank you, guys. Bye-bye.
Thank you.
Thank
Thank you,
you.
Abhi.
Thank you.